Hello everyone. Today we are going to discuss a SuMON math problem from fortnight 33 of level 3. This is a harder one and it involves coloring type question. We have to find the number of configurations that follow the given condition. Let's get started. Here is the question. Consider a m cross n rectangular grid where m and n are positive integers and into mn unit squares by drawing grid lines. So we are going to form a rectangular grid structure. Let's take a quick example. Let's consider 4 cross 6, 4 rows and 6 columns. So a diagram would look like this: 1, 2, 3, 4 rows with 1, 2, 3, 4, 5 and 6 columns. And now capital N is the number of ways to color the cells in this 4 cross 6 grid, or in general m cross n grid, such that every 2 cross 2 grid contains exactly 2 units of red and green colors. So the colors you're going to use are red and green ultimately, and you have to obtain 2 unit squares of each color. So out of 4 squares you choose in the 2 cross 2 grid, you need to obtain 2 squares of red and 2 squares of green. Let's take, for example, this box. And if this is the configuration of green, then you should have the other 2 as red, so that you have equal distribution. So that is the goal of this condition. You have to find the value of n in terms of small m and small m, the lowercase m and n, which is the dimension of the grid. Also, an interesting further question asks you to find the fraction of these n colorings that have the least possible red colors colored. Okay, first let's analyze the capital N possibilities. You see, if I color the first row alone, let's use the green highlighter for that and the red one. Notice I'm doing this in random. There is no justification behind that or no procedure in that. And there are in total 2 power 6 ways, as there are 6 cells in that row and each cell has 2 possibilities, either red color or green color. So 2 possibilities for the first cell, 2 possibilities for the second cell, and all of them multiply because they are independent and occurring simultaneously. So you have to do in general. There are n columns. If you consider m cross n, there are n columns. Equivalently, you will have 2 power n ways to perform this. Now you see, if some 2 colors are adjacent and equal, some 2 same colors are adjacent, then the following row must have the opposite colors that are also adjacent, just below those 2 that are same and adjacent. You see, here 2 greens are same of course and adjacent, so they are followed by red in the subsequent row, and this determines the color in the remaining cells of that particular row. This is because if you box out the 2 cross 2 that has just one cell empty, then it is clearly determined by the remaining 3 colors. If you have one green lesser, as here, you are going to add one more. Same goes here. If you analyze this box, 2 cross 2 box, you are going to have 1 cross 1 cell empty, and that is determined by the remaining 3 cells color. So it is green, and further they will complete the cells that are concatenated to the sides, the lateral sides. So hence this completes the entire coloring. So hence it is deterministic if some 2 colors are equal at some point along the coloring of the first row. Therefore, and do notice that this property is propagating towards the rows as we progress. Now the third row will also have that property of 2 adjacent greens just beneath the 2 adjacent reds. So due to this propagation, you are determining the colors beforehand and you don't have any further choice. Therefore, you are going to have just one possibility for this one way of coloring. Similarly, 2 power n possibilities for 2 power n ways of coloring the first row. But wait, I assumed that some 2 colors are adjacent, some 2 equal colors are adjacent. This is a special condition, we can't impose it. for all those 2 power n configurations. So let's subtract that. If no two equal colors are adjacent, then clearly the colors are alternating. Now the alternating colors can happen in the following way. Start with green and the colors alternate, or start with red and the colors alternate. So you have 2 options for these and no more. So you subtract 2 from this, and rest all coloring of the first row will definitely have some 2 equal colors adjacent, and therefore there are 2 power n minus 2 ways to color. And for the remaining 2 ways of alternating colors in the first row, we can have 2 possibilities in the subsequent row. Either let's take an example to verify that. Suppose you start with green and you then go with red, green, red, green, red. Then the second row clearly has 2 possibilities. If I start with red, then the coloring is again deterministic by including the 1 empty cells. So you have green here, green here, green here, red and red here. Or if you don't wish to do that, suppose if you start with green, well, again the colors are determined of the entire second row. You're going to have alternating reds and greens again. So in either way, the subsequent row is consisting of alternating colors, but again you have 2 possibilities. Now since each of these rows have 2 possibilities for alternating colors, including the first row, the answer is just 2 power m, 2 power the number of rows, because each row has 2 possibilities. And since they occur simultaneously, you have to multiply the possibilities for each individual one of them. Alright, we will gather them now into a single entity. Capital N is these 2 power n minus 2 ways of not having an alternating configuration plus 2 power m ways of having alternating configuration, and this yields 2 power m plus 2 power n minus 2. Now as you could see, the expression is symmetric about m and n. That is, if you interchange, you are going to have the same, which is consistent logically, right? So verification of this for the whole coherence is quite important. Now the second question asks you to determine the fraction that contains the least possible red colored cells. Well, here you have to do some caseworks. You see, if m and n both are even, you can box it out into 2 cross 2 square grids to completely pave the rectangle. You can completely pave the rectangle by blocking out the 2 cross 2 square, as you could see in this particular example. Now each of these will definitely have 2 red squares, so totally you are going to have a constant number of red cells, red colored cells. So that means each configuration is going to have the least, as they all have the same red cells. So this is configuration independent, and therefore the answer is just 1. So the question might not be very interesting when both are even. So when m comma n are even, that imply fraction equal 1. Alright, if m is odd and n is even, this case is pretty much interesting, that you can pave the rectangle in one way but not in the other way. For example, a simple odd number is 3. So you take 3 cross 4. That means 3 rows with 4 columns as shown. Now, since 4 is an even number, you can pave it along the columns. That is, entire column is paved except one complete row that remains unpaved, right? So this one might not have a predetermined or a pre-qualified number of red colored cells. So I can tweak around the values here to minimize the number of red cells. Just do the green coloring throughout the row, simple. And whatever you are going to do, you will ultimately have 2 red here and 2 red here. That's it. So this is the least. And you can of course have the first row with all green and the next 2 columns such that they both are red. Now this is going to give you the total number of colorings with least red colored cells, as you cannot go further less. So now it is about ultimately choosing the row for which you are going to insert all greens. So there are 3 possibilities, and in general m possibilities if m is odd, and then you have the options to color them, where you are going to manually fix the color. You see, the subsequent row would be all red and the other one will be all green. So essentially it is the permutation of these three rows. So you are going to have m choose m minus 1 by 2 ways of doing this, because you are going to choose m minus 1 by 2 rows for inserting all red. So here the fraction is thus m choose m minus 1 by 2 divided by capital N. Alright, the last, and of course m being even, n is odd, would yield n choose n minus 1 upon 2 divided by capital N. Now the concern is about m and n both are odd. What would happen if both are odd? So let's take a 3 cross 3. 3 cross 3 is quite simple, but you can extend the argument, of course. So if you pave it with 2 cross 2s, you will be left with 1 row and 1 column completely vacant. Now how effectively are you going to color them so that you are going to have minimum number of red? This is by inserting all greens in one column, and this is going to give us an alternating configuration in the other rows. Or equivalently, you may have all greens in one column and alternating colors in other row. So this is justified just by taking some primitive configurations for start and derive the subsequent coloring, and you will be able to realize this. So if you do this, of course the obtained configuration will be like green, red, green, red, green, red along the columns, or green, red along the rows. So this is going to be in the following way. Either you do it row wise, so that is be m choose m minus 1 upon 2, or you are going to color it column wise, so n choose n minus 1 upon 2. This is for inserting the red colors, because n minus 1 by 2 is on the lower side. So that many ways divided by capital N. This is the underlying fraction. So in our problem worksheets, we try to include lot of such interesting coloring type problems. Even smaller grade kids get intrigued by this, not intimidated by this, and hence we foster a creative thinking ability inside each kid. And I hope this increases the longevity of kids' mathematical thinking. Happy learning everyone. Bye.